Hey, so welcome to our notes for inequality and interval notation. We're going to go through example 1 pretty quickly because this is review from Algebra 2. If x is strictly less than 2, then that means that it doesn't include the 2. So on the number line here at 2, remember from Algebra 2 that when something is non-inclusive, it's not included in the solution, we use an open circle, right? And since the x's are less than 2, we're going to shade down the number line toward negative infinity because we want everything smaller than or less than the 2. And when we want to put that solution into inequality notation, non-inclusive, we use greater than or less than. There's no equals with it because we don't include that endpoint. So the x's being less than 2, remember the alligator eats the bigger number. So the inequality is going to face the 2 because the 2 is bigger than the x. So this is x less than 2. This word strictly here is kind of a distractor. It means the same thing whether that word is there or not. X is less than 2. It still doesn't include the 2 as an endpoint, so x is strictly less than 2 means the same thing. Okay, in the next row, instead of starting with the verbal statement, we're starting with inequality notation, and we're going to use that to generate the graph using open and closed circles and then a verbal statement. So remember the alligator, since it eats the bigger number, the x has to be bigger than or equal to the 4. So x is greater than equal to 4. It means we're going to have a closed circle at 4 on the number line because the 4 is included in the solution, and that's called inclusive. So in your notes you want to write down that we use a closed circle for inclusive values, and those are whenever we have an equals with our inequality. So we use with less than equal to or greater than equal to. Okay, so since we want the values to be more than 4 or greater than 4, we're going to shade up the number line toward positive infinity. Okay, so for the verbal statement, you could absolutely write that x is greater than equal to 4. You could say x is more than 4, but includes the 4. The way that I chose to write it in this example is that x is at least 4, and that means the same thing. At least is implying that the 4 is part of that solution as well as anything greater. Okay, so in the third row, now instead of starting with the verbal statement or the notation, we're given the graph. And you'll notice that when I draw them, I usually put the shading and the circles right on the number line. You can also do them above the number line. It's just a preference with certain teachers or textbooks. It makes no difference to me. You can draw them above or on the line, whatever is what you're most comfortable with. But we want to, in either case, look for where the open and closed circles are and where the shading is. So in this example, we have an open circle at -3, and the shading is heading up from there. So that would mean that the x is greater than -3. But it stops here at 2 and doesn't keep going. So this x greater than -3 can't be the whole answer because we need it to also say that the x is less than or equal to 2, because at 2 we have a closed circle and the shading is going down the number line. So for these things both to be true, right, that would lock the shading in between, and that's a compound inequality. Instead of writing this all out as x greater than -3 and less than or equal to 2, we can simplify that notation by using the compound inequality -3 is less than x, which is less than or equal to +2. right? Those say the same thing. This is just an easier way to represent it, more simplified in the notation. So we can write it that way because this shading is between, and that's how I'm going to write it in my verbal description, that x is between the -3, which is non-inclusive because of the open circle, and the 2, which is inclusive because of the closed circle. And again, the verbal statement, there's lots of correct ways that you could write that verbal statement. This is just one of those ways. Okay, so then in our last row here, we have another graph, and this time instead of the shading being between the values on the number line, it's shading away, right? And that means that we won't have an and compound inequality. Instead, we would have an or, because it's either shading down toward -infinity, or at the 4, it's shading up toward +infinity. So we know, since there's a closed circle at the 1, that the x is less than or equal to 1, or the x is greater than +4. And this sort of inequality you cannot condense into a compound statement like what we have with the and, because you can't put the x in between those. So we would write it out as x less than equal to 1 or x greater than 4. And then our verbal description here is going to say that x is less than -1 inclusive because of the equals, the closed circle, or you could say strictly greater than 4 or just greater than 4. Remember that strictly isn't strictly necessary. Okay, so we're going to do example 2 in the next video, so we can keep them separate. And if you need to go back and review these notes or copy anything else down, feel free.